are of note, secant squared, the Pythagorean, this comes out of the sine squared plus cosine squared one. Secant squared equals tangent squared x minus 1, and tangent squared equals secant squared plus 1. Those, like I said, those come out of the sine squared plus cosine squared equals 1. You can get those out of those, but those are the two that we'll use. So we're going to replace secant squared sometimes by tangent squared minus 1, and tangent squared we're going to replace sometimes by secant squared. Did I do those wrong too? Secant squared is tangent squared plus 1. Tangent squared is secant squared minus 1. Check me on those. The paper's got it right. Okay. This is good. Okay. Secant squared is tangent squared plus 1. Tangent squared equals secant squared minus 1. Okay. Here's a couple of general strategies. A, if tangent is odd, power, save a factor of secant tangent out. And express the remaining tangents as secant, in terms of secants, okay, using this identity. Okay, that's what you do if the tangent is odd. If the secant is even, here's what you can do. Secant is even powered. Save a factor of secant squared. So it's complicated because the derivatives of secant and tangent are not quite as nice as sine and cosine. But anyway, save a factor of secant squared and express the secant, the remaining secants in terms of tangents. And then we'll use U substitution like we did. Which may not make a whole lot of sense right now, but hopefully they will. Somewhat. It gets complicated, yeah. Yeah, like I said, it's got to be pretty special. I mean, you got to have tangent to a power and secant to a power for this to work. So yeah, if it's only tangent, if it's only secant, which I think probably I'll mention that too later, but okay. So let's do one. Tangent to the 6th, integral tangent to the 6th x, secant to the 4th x dx. Okay, so on our strategies, we either got to have an odd powered tangent or an even powered secant, or these strategies do us no good. If you have something different, you have to go some other route, and it gets complicated, as you might guess, because it's already complicated enough with this. But the good news is here, we do have one of those two laid out for us, right? We've got an even powered secant. So if we have an even powered secant, we save out secant squared, so that would be what? Tangent to the 6 x times, well, it would be secant squared and secant squared, right? So I'm going to save out secant squared x dx. And you might guess why I'm saving out secant squared, because I'm going to do u substitution, and u is going to be tangent. And if u is tangent, the derivative of tangent is secant squared, you see. That's why we're saving out secant squared. Okay, then what do? Put the remaining secants in terms of tangents. So here's the remaining secants. It's a secant squared, and it turns out secant squared is tangent squared plus 1. So we have tangent to the 6th x, tangent squared x plus 1 times secant squared x dx. Works out good again. Actually, now this one is going to work out pretty well. It's going to be like the first sine cosine one we did. That's the only good news I got for you. All right. So that'd be tangent to the 8th x plus tangent to the 6th x times secant squared x dx. And yes, a u substitution is going to work out nicely here. U is tangent, so du would be secant squared x dx. That's going to work out nicely, isn't it? Because the secant squares are going to cancel. So we have the integral of u to the 8th plus u to the 6th times secant squared du over secant squared. Secant squareds cancel. And so we just have a u to the 8th, u to the 6th. All I've got to do integral of. With me? So that's 1/9 u to the 9th, 1/7 u to the 7th, antiderivative, plus c. U is tangent of x. So it's 1/9 tangent to the 9th plus 1/7 tangent to the 7th plus c. One more. Hang with me? All right, so this one's going to be the integral of tangent to the 5th theta, secant to the 7th theta, d theta. Do some thetas. Okay, well, yeah, this is an example of the first strategy, because I've got a tan that's odd. The secant is odd, and secant odd doesn't help me one bit, but tangent odd does. Because if I have a tangent that's odd, what do? Save out a secant tangent. So I'm going to pull out, I'm going to do a secant theta, tangent theta, or tangent theta, secant theta, d theta. I'm going to save those out. So what does that leave me over here? That would be tangent to the 4th theta, secant to the 6th theta. With me? I'm saving out the secant theta, tangent theta. Pulling that out of these two. And you'll see why here in a second. Then I express the tangents in terms of the secant. Well, what do I know about tangent in terms of secant? Well, tangent squared x equals what? I got it wrong a while ago, so secant squared minus 1. Tangent is secant squared minus 1. So, I've got tangent to the 4th. What am I going to do with that? Tangent squared squared, yes. I'm going to say this is tangent squared theta squared. Secant 6 theta, secant theta, tangent theta, d theta. Yeah, I'm going to think of that 4th as squared squared. Then I can replace tangent squared by secant squared. So it'll be secant squared theta minus 1 squared secant to the 6th theta, secant theta, tangent theta, d theta. Okay. Making it way long there, but it'll pay off. Okay, well, I got to square this thing out. Secant squared theta minus 1 twice. Cut to the chase there, so that would be the integral. That would be secant to the 4th theta. Secant squared minus 1 would be minus secant squared, but then I'm going to have another minus secant squared, aren't I? So minus 2 secant squareds. And then I'll have minus 1 is plus 1. Times the secant to the 6th, secant theta, tangent theta, d theta. It's getting even longer. Let's make it a little bit shorter, because then, what do, you think? Distribute the secant to the 6th. Okay, so that would be the integral of secant. Well, secant to the 6th times secant to the 4th would be secant to the 10th. Minus 2 secant to the 6th, secant to the 2nd would be secant to the 8th. Plus secant to the 6th. Then times this secant theta d theta. Secant theta, tangent theta d theta. Excuse me. And I'm going to let u be the secant. And then du is secant tangent d theta. So yeah, that's going to work out pretty well, because du will be the secant tangent, du over secant tangent. So that's going to work out nicely, canceling out there. All right, so that would give me then what? U to the 10th minus 2u to the 8th plus u to the 6th. Secant theta d theta, but d theta is du over secant tangent, so aren't those going to cancel? These secants are going to secant tangents are going to cancel with that, so it's just du here, isn't it? Now, this power rule. 1/11th, u to the 11th.